Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Now that we have fully implemented level 1, it is time to address level 2. Now level 2 is basically the same as level 1, apart from a few extra new tile codes that we have not implemented yet, which is the flame wheel bot, the needle, the TV, that has Dr. Proton taunting Duke, and of course the floating tech bot. So in the upcoming episodes we will implement all of these one by one. Alright, let's go. So the easiest way to figure out which tile codes we have not implemented yet for all the upcoming levels is to just print them out while loading up the level. So what I've done is I've went through this entire list of tile codes and added them to the level class where we process all the tile codes when we're loading up the level. So here in the init function, right here we add all the active, like we've implemented a bunch already. But we also still have this list of tile codes that we don't have any code for just yet. And so what the game will do is it will just print them out as we load up the level. So we get a list of tile codes that we should implement in order to fully support that level. So yeah, let's just go ahead and print them out. So let's load up level number 2. And then here we can see a nice little list. So we have 3000B, we have 2C, 41. All right. So let's take a look at 3000E. That's the 2x2 rotating wheel with flames. That's an enemy. Fine. That's this guy here. 2C. Let's see. 2C. That is the spike that pokes up when Duke walking over. All right. Yep, we can do that. B. That's this guy, the 1x1 floating robot with purple antenna. Yeah, that's an enemy. And the 41, which is that one. 41. That's the screen display with Dr. Proton. All right, we'll leave that probably a bit later. We'll start with the spike poking up. Just an easy one to get ourselves into it. So that's 2C. So that's this guy. So it's sprites number 45 and 46 in object 1. So let's open up our object and let's see if we can find it. So that's these things here, right to the left of the magenta flag. Okay. So that is 2C. So let's take that out of the list here. And let's add it at the proper place. So A, B, and C. New, I don't know, needle or something. And then copy probably the top tile. Let's put it in the active class package. And then let's make an update method that says if Duke, so I guess we should assign Duke. If Duke collides with this, then we should hurt Duke. And let's keep a boolean that says something like poking. So boolean poking is Duke collides with this. If the needle is poking, then hurt Duke. And then here in the render method, we'll just say that the int tile index is, if we're poking, it should be the one protruding. So it's to the left of the magenta flag. So let's take a look at the flag. It's tile code 96. And otherwise it's 95. And then we can say render draw tile assets get object tile index XY. Okay. Oh, there we go. Okay, so this should in theory add this new, oh man, the sound is really loud. Let me just go it down a bit. Okay, let's try and find the needle. So here we have a few. So they're just down there doing nothing, and if we walk over them, they poke up. So that works. All right, so next up, let's do the do a new enemy. So let's go to the Duke 1 level format once again, and let's find one of the missing enemies that we have. So that is tile code 3000E, which is the 2x2 rotating wheel with flames. And it's in the anim1.dn1. So let's open up the anim PNG and let's find the enemy. And this is the one that I'm talking about here. This big flame wheel thing here. That is a 2x2 graphic, kind of like Duke himself. So let's do it. So let's find 3000E. Here it is. And let's add him here. And let's call it the new flame wheel bot, I'm guessing. And then copy the left tile. And I guess we'll just suffix this with bot as well to make it clear. So Duke active enemies. And then let's extend patrol bot, because this guy is going to patrol left to right. So let's start by going left. And speed is 4, I'm guessing. And yeah, let's just first start by rendering this guy. So it's 4 tiles, so let's get the base tile. And yeah, let's see. So we have anim1 starting at 0. So that's 50 for us. Then let's have the renderer draw tile assets get anim 50. And then let's do XY. And then draw the rest. So that is, sorry, base tile. And then we have base tile plus 1, base tile plus 2, base tile plus 3. And then, yeah, the way that this guy, his hitbox works is that this is the hitbox, like the little center here. And, yeah, here. So that means that it's offset by 8 pixels, and the width and height is 15 by 15, like one tile. So that means that top left is -8 for the X and minus tile size for Y. And then top right is X plus 8, and then Y minus tile size as well. And then the bottom left, X minus 8Y, and then bottom right, X plus 8 and Y. So this should be the bot. Let's animate him right away. And yeah, frame equals frame plus 1. And we have 4 frames. So each frame comprises of 4 tiles, so we have to multiply the frame by 4. All right, so let's load up the game. And let's see if we have this bot patrolling. Okay, so here we go. Now the original bot is moving, I think, every other frame. So let's override the patrol method. Because here this guy will set a velocity. So what we should do is we should only patrol if frame happens to be even. Because like I said, I think this guy patrols a couple of pixels every other frame. So let's see his patrol speed now. Okay. So, and then I think his speed should be 8. So I made a recording of this guy. So let's take a look here real quick. Yeah, so I think every other frame. How do I close this? Oh, like that, okay. So I think this guy, yeah, moves 8 pixels every other frame. So I think this is the correct speed and patrol frequency. So let's check it out one more time, and then let's move on to the flame part. Yeah, so I think this looks pretty good. So now all that leaves to it is, you know, we need to be able to shoot this guy, of course, and kill it. And we need to have his flames go on and off. So let's keep a timer for the flames as well. So we got frame and we got flame. And then flame equals a flame plus 1. And then the flame will cycle every 32 updates, I think. So let's make a boolean is flame on, or return flame greater than or equal to 32. And then here the base style, if flame is on, the base style should be 66, otherwise it should be 50. Okay, let's see if it cycles between flames. No flames. Still no flames. Okay, why not? Oh, right, of course. 64. Sorry. Yeah, there we go. So now he cycles between flame on and flame off. Not sure about the frequency. Might be a bit too short, but I think it's okay for now. Flame 64, 32. Yeah, okay. So that means that now all we have to do is fix the shooting of this guy. So let's override the hit method. And then here we say that if the flame is not on, then we'll decrease the health. The health of this guy is 2. Let's initialize it in the constructor, I suppose. Health equals 2. And then in the update method, we'll say if health is less than 2, then we'll spawn some smoke. And let's see, I guess X plus 8 and Y is the correct smoke position. Add effect. Sorry. There we go. Add effect. Smoke. And yeah, if the health is actually 0 while you shoot it, then we'll increase the score by 200. We'll add an effect. Sparks, I'm guessing. And we'll spawn some particles. And we'll set active to false, of course, to make this guy disappear. Okay. So let's wait. Okay, flame is on. Nothing happens. Okay. Smoke is not in the correct spot. And a bit too often. And there we go. We killed it. So yeah, let's smoke every 6 frames, I guess. But frame only goes up to 4, I think. So I guess we'll just do every 4 frames. We'll add a smoke. And then Y needs to be a bit higher. And I guess the same goes for these effects as well. Okay, let's check it out. Okay, that's looking pretty good. And boom. Okay. Let's also do a smoke when we kill it, I guess. I have no idea what the what effects exactly happen, but this is fine. Okay, so that is the flame wheel bot. I guess we can also play a sound when we kill this guy, but I'm not sure which sound it is, so let's add that as a to-do, and we need to add a lot more missing sound effects in other spots as well. Okay, so those are already 2 more enemies that we've already implemented. So that leaves us with the Dr. Proton TV. Now the Dr. Proton TV actually requires us to implement the game camera a bit differently now, because the TV has a behavior that is tied to whether or not it's visible to the game. Because if it's outside of the visible playing area, the TV will go to a static mode, and the first time Duke enters the visible area of the TV, it will display the message. So I think the very first thing that we should do is actually extract the camera outside of the GFX class so that we can expose it in our game state. So let's make a viewport class here, and let's keep the X and the Y variables here, and let's have a public void update where we have the game state, and let's take the code from GFX here. So I think we can take this stuff out, and let's move the viewport actually to the root here, because it's not an active class, it's just some other thing. All right, and then we'll keep these things here, and then we'll go to GFX. And then we'll take out the, let's see, this resource loader can go. Don't need it outside of the constructor. Yeah, so let's take this move camera method here. Let's take that one out. Let's go back here, and then here in update. Here we can just replace all the camera prefixed X and Y coordinates with just regular X and Y. Import tile size here. Okay, and yeah, let's make a getter for X and Y, because we probably will need it, although I'm not too sure if we do. Okay, and then we'll need a public boolean is visible, any active tile, a return active collides with our X, Y, and then what's our width and our height. Now our width is of course this part here, so that's like what, 12, I think we had like 12 tiles, right? Let's go to GFX. Where's the render? Here. Yeah, so it's 12 rows and 15 columns. Okay, so that's 15 times tile size, which is 240. And the other one was 12 times tile size is 192. All right, so if an active tile collides with our camera, then we are visible. So let's expose this one in the game state. So I guess we'll just have it way up top, viewport. Let's make a new viewport. And in the update method here, we'll update the viewport. Now the viewport actually depends on Duke's position, so we'll just put it just below Duke here. All right, and then after we update Duke, we'll update the viewport, and then we'll go to GFX. Let's delete this move camera thing. And then we probably have some compile errors, but I think easiest for us is to just keep track of the viewport. And of course I forgot to add a getter for the viewport here, so let's get Duke, get viewport. All right, and then here we can say viewport get X, viewport get Y, viewport get X, viewport get Y, and then here we also have viewport X, viewport Y. All right, let's run the game and see if it still works. Yeah, it's looking pretty good. Okay, so what we can do now is we can implement the Dr. Proton TV as said, and the TV has a certain behavior when it becomes visible. Now the TV sits in the background as well. So what we can do is we can first go to the level class, and we'll add the TV here, 3041, add a new TV, copy node tile, create class TV in the active package, super X and Y, and then here in update, if state get viewport is visible this, then we will do stuff. Now the TV is in a certain state, either it's off, it is tracking Duke, or it is displaying some static. So private state state. So it should start off. And then as soon as Duke has, comes into the viewing area where the TV is located, we should start broadcast here. So, I don't know, private avoid broadcast. And I guess we need game state, show modal, new modal, state, get level, get message. So how do we do that in the message class? I guess we have the, okay, so I guess we'll have to do the same for the TV for now. So private string get message int level return switch level case 2 surprise Duke. I think it's a bit longer. We'll check it out. And then default, we'll just do no message. Yeah, so new modal tile size 48, get message, and then exit on enter. Get level, get number. Okay, and then we'll set the state. This dot state is tracking. And if the TV is not visible, then we'll set the state to static, unless it is off. So if it's not visible, if the state is tracking, then we'll go to static. Otherwise, we'll just remain off. And then here, broadcast state. Okay. So we won't render anything just yet. So for now, I think what I'm expecting is a pop-up to show as soon as we get near the TV. Surprise Duke. All right, so now we get the surprise Duke every update. So of course we only want to check if the state is off. Then we want to broadcast. So the first time you encounter the TV, broadcast. Okay, so that is the behavior for now. Yeah, so let's draw this TV. Now the TV is located in the anim package, all the way to the right of this white square. So this white square is used in the reactor. So let's give it a quick look up here. So when we hit it, then it's 265. That's the white square. So 266 is the first TV graphics. So let's go to GFX. And we'll do the same as we do for the exit door. But we'll just say like, hey, TV tile ID plus how many frames does the TV have? 2, 4, 6, 8, 10, 12, 14. So we got 14 TV IDs. Now the exit door has 16, so that's 17. Okay, so 17, so where's the TV here? So we have the TV tile ID, that is 17. And we'll do the same creation methodology that we do for the exit door. So I'm just going to copy that stuff over. So we have the create and the update door, and I'll just make a TV create XY level, and then update TV, and then TV tile ID as the base tile ID, and then return new TV. Let's see, we can do better. Row is Y divided by the tile size. Col is X divided by tile size. Then we'll just, because TV has fixed tiles here, so we got the TV tile ID, and right next to it we got the TV tile ID +1, and then we can say update TV, and then right above it because when you look at the TV, this part is always the same. It's just this part here that changes. So the TV is in either this static state or in this tracking state. So we'll just name these frames 1, 2, 3, 4, 5, 6. So we'll just say like, hey, we have some sort of a frame offset here. So when we create the TV, we'll just default to frame 1. And then as soon as we enter the TV's visibility, then of course it will update and show the correct graphics. Yeah, so Y minus tile size is the origin for the TV. And then here for the update TV, we have we only need to set 2 tiles, the top 2 ones. So we can just say row, column, and then TV tile ID plus the frame that we're in times 2, because each frame has 2 tiles right next to each other. So I'll just calculate an offset here, frame times 2, and then here we'll just add the offset to the TV tile ID, and here we'll say offset +1. All right, and then we'll go to level, and where we do new TV, we can just do TV.create XY level. So that's this. This will create the TV. Let's go back to the TV class. Where are we? Here. So this can be a private constructor. We need to set the width and the height. There we go. So if we're visible and we're off, then broadcast. Otherwise, if we're tracking, then go to the static mode. And yeah, well, after we're done updating the state, we can just say like, okay, update the TV code. So get level XY, and we need to figure out which frame to show. So we can do that here. So switch state, case static, this.state. In the case of static, frame is I'll say frame +1 %3, and I guess we need to keep track of the frame, private int frame, and then we'll just of course have to start with 1. In the case that Dr. Proton is tracking, we want to do something similar that we're doing for the cameras. So we want to decide the column that Duke is in. And then what we'll want to do is say like, okay, is Duke to the left or to the right of our column? So we can just say, hey, compare these two columns to each other. Okay. And then we can go here. And then we can say, if these tiles are found in the level data, then grab image is assets get anim 266, I think we said, plus the tile ID minus the TV tile ID. Same as we do for the exit. Okay, so let's run the game and see if the TV is behaving. Surprise, Duke. So we got Dr. Proton following us, and now when we leave the screen and go back, I expect static, and there we got static. So that is working. Now all we have to do is that if we are colliding with the TV and we are using the TV, it should also start broadcasting. So let's go to our TV class again. I'm not sure if Duke can always do that, but let's just assume that he can. So if collides with this and Duke is using, then we should also just broadcast to Duke. Okay, so again, let's head over to the TV. Surprise Duke. Okay, so Dr. Proton can follow us. And when we press up, when we add the TV, he also surprises us. Now the TV is empty, pressing up, and he's looking at us again. All right, yeah. So I'm liking it. So yeah, I think that's enough for this episode. We've implemented the TV and the needle, and we've externalized our viewport here, which will help us also update certain active classes. Certain active classes should only be updated when they're actually visible, such as the boxes, like you see them dropping all the time when they move into view. But we'll fix that later. But for now, at least we have the possibility. So next episode, we will implement the floating bot, and that will complete level 2, because I think that's the last tile code that we need for level 2. If we take a look here at the missing tile codes, that's 3000B, which is the bot, the floating tech bot. So join me for that one. If you have any questions, then feel free to put them in the comments down below. And if you like the series, then please drop a like and a subscribe. It really helps out a lot. And I'll see you guys in the next episode. Bye-bye.